What's going on, everyone? Can you let me know in the chat if you can hear me okay? What's going on, everyone? Hope everyone's having a good weekend so far. Let me just make myself bigger here. Right there. That should be good. Okay, so welcome to the stream. The stream this week is we're talking about programming languages, kind of in the abstract. It's gonna be more of like a philosophical sort of stream. I've prepared of a bunch of different code in a bunch of different languages, and we'll talk about those. Talk about some of the history, like what applications you might use certain languages for, and certain libraries you might use, and various other things. So in the chat, if you have a question about a specific like language question, not like specific, not like how do I do a list in Python or how do I do an array in PHP or something like that, but more like, who thought up a language, or why did it come to be, what was it influenced on, any sort of philosophical kind of questions about programming languages. If you have any of those, go ahead and put them in the comments, I'm sorry, in the chat, and then I will answer one or more of them on stream. So go ahead and do that now, and I want to talk briefly about kind of what happened, why the stream was canceled. I know everybody's probably wondering, and then chat a little bit about EMKC and the channel and things like that. So first, I know the stream got canceled, and people that know me in the server know there's only one reason why streams get canceled, and that's because my dog was sick. And I told myself that at the time I canceled the stream, he had not eaten in about 48 hours, no food or drink, and I was starting to get a little concerned. I told myself that if I woke up that morning and he was still not eating or drinking, that I was going to have to go take care of him. So he is all better now. He's good to go. Everything's great. He's doing some napping right now. So as far as the channel's doing good. We are approaching 200,000 subscribers, which is amazing. I know I still haven't done the 100,000 subscriber video. I don't think I will at this point. I'll probably do a 200, and then we'll see where we go from there. I have a couple ideas for a special. I had some special videos I was thinking about doing for the 100,000, but none of them ever panned out, so I didn't end up doing any of them. And then by the time, time just went so fast and subscriber count grew so quickly that 130, 140, 150,000 showed up so fast that I didn't even have a chance to do 100,000. And the same thing's happening now. So I'm going to do a 200 for sure. Serge Rotberg, thank you very much for that. Glad your dog is okay. He is. Myself and Chase, thanks you for that donation. He's doing good. It ended up being nothing really. They looked at him. They think he just ate something bad, and so all's good there. Thanks a lot. So channel's good, EMKC's good, everything's good, good to go. So let's go ahead and let me see if there's any questions here. Also, Serge, make sure let one of my staff know on the Discord server, and you get a special role for supporting me here. So let them know that, and they'll hook you up with that. Okay. Soul Hunter said, how can Python be used for network? So most languages will implement some sort of way to interact with the network, and of course Python's no different. Thanks for the 5 fidget, Felix Food, great. I hope everybody enjoyed the GIF. That was not the GIF, but the animation at the beginning of the stream. I'll give Felix some nuts and bolts and transistors to keep him running, but that animation was made by Senior Ducky, longtime staff member. let's see, G moves when you're flowing and really getting good work done, how do you handle running into a problem you don't know how to solve, come back to it later, bookmark it, etc. So it usually what I do is I try to take a step back and I try to look at the problem as a whole, because oftentimes these problems are not as complicated as they seem on the surface. So I try to take a step back, try to look at the code flow, and then I just try to dial into what exactly is wrong. The other thing I do is I start at the last known working point, and then I work down to the point where it doesn't work, and then I'll just keep going down until something goes wrong, and then I'll just look at it from there. But if I do get frustrated, because that happens, every programmer ever is going to run to a situation where they're going to be working on a problem a lot, and they're not going to be able to get it. It's going to be hours, and they're going to get frustrated. It's easy to just take a step back, go get a drink, go take a walk, go do something, go play some video games, and then come back and get it done. That way you have a fresh mind. Okay, what was the reason for canceling the stream? Yep, answered that. Let's see. Yes, Kuketso. I'm sorry, I can't pronounce that last name. Would you recommend I learned a faster to write but slow to execute programming language, or a slower to write but fast to execute programming language? That's actually a fantastic question, and it actually hits at the core of this stream. Is languages as a whole are either really, really complex to write and very verbose. However, they run extremely fast. An example of that would be assembly language, the lowest level you can go where it's still human readable. And then on the other end is something like JavaScript, where it's extremely easy to write. You can get a lot done in a very little bit of code. However, it runs slower than the other languages. It runs slower than the languages that are extremely tough to write, such as assembly or C or something like that. Okay, a lot of questions here. So what I would recommend, see, back in the day, resources weren't so readily available as they are now. Today in 2019, we have processors that are orders of magnitude faster than the processors of last decade or even 2 decades ago. And also RAM. I remember back in 2003, I had a computer that had 64 megabytes of RAM. And here in 2019, I got 128 gigabytes of RAM. So I have, what is that? 400 times the RAM. And it's only going to continue going up from there as long as we can continue packing more and more things onto circuit boards. We're going to continue to make faster and faster equipment, and it's going to continue being cost effective. So in 2019, it's actually less important to write highly optimized code and more important to write it fast and get your product to market. Some people will disagree with me on that. That's part of that's opinion based, but part of that's fact as well. The fact portion of that is that our hardware is way better, which means back in the day, maybe making something more efficient from like 10 milliseconds down to 9 milliseconds might have been a big deal. But today, not so much a big deal. We have crazy hardware. Now, that isn't to say that you should just write garbage, inefficient code. Of course, you want to aim to write the best code you can, but don't micro-optimize for the sake of increasing performance by 1%, unless your particular use case requires it. There is still a lot of real-time programming. There still is programming on embedded devices where RAM and processing power is limited. In that case, you're going to want to write the most efficient code you can using a lower level language, such as like C. So to answer your question, if you're doing things like web and mobile, just go for the quick to write stuff. But if you're doing things that are performance critical, things on embedded devices, then you're going to want to learn a fast executing language that might be a little tougher to write. That'll serve you better in that case. What do you know about logic programming such as Prolog? I actually don't know anything. Somewhat embarrassed to say, but yeah, I can't do anything with that question. You should let me know something about Prolog, either here or in the Discord server. What's your take on functional versus imperative versus OOP versus anything else? I think they all have their place. I mostly do imperative programming with some OOP. I don't do a whole lot of, I use functional languages, but I don't know that I use them purely functional, if that makes sense. Like JavaScript, for instance, is a top-notch functional programming language, but it's not just that. You can write in an imperative or OOP kind of way. So I think it just depends on your use case for the program that you're writing, but a lot of, I think there are some languages that are purely functional, like you must do it all like that. However, I don't write in any of those. Primarily what I write in is Python and JavaScript, and of course I have a number of different things I can do in those to get my program to do what I need it to do. What's your favorite programming language? It's got to be JavaScript. It has to be, because it's at this point it's ubiquitous. It's only going to be another 5 years before everything's written in JavaScript. TVs, toasters, microwaves, anything you could possibly think of. Let's see. What do you think about Dart? So I think so Google, of course, Google has this sort of thing that they've always done, which is to make people love their stuff. Whether that's Hangouts or Google Plus, they tried to make people love it, and now Golang, and of course now they want to take into the browser and use Dart. So I don't know a whole lot about Dart other than its history. I've never actually used it to write anything, so I don't know a whole lot about it, but I think it's worth looking at, but I don't know that I don't know that I would reach for Dart for any serious project today, in March of 2019. Do you listen to programming podcasts? If so, what? I don't. What distro do you use? I use Xubuntu 18.04, which is a Linux distribution. Professional Pizza asks, why learn assembler? So that depends. If you are a programmer that just uses Python and you get by with Python and you don't need to do anything lower level than Python, then the answer to that question is you don't need to. You don't have to learn assembler. The reason learning assembler, or at least having familiarity with assembler, is good is because if you are working on low-level things such as device drivers, or maybe you're doing some Linux kernel hacking, there's going to be a case where you're going to convert that C code into assembler, and then you may need to go in there and hand code some of that assembly to make it even faster. Of course, GCC, which is the GNU compiler collection, which is what turns C source files into assembler code. It's of course not perfect. A human had to write GCC to convert to assembler. So there are going to be cases where you can hand code some assembly to make it quicker. Now keep in mind, that's an extremely advanced topic. It's actually even beyond what I know. I don't know that I would even be comfortable going in and hand coding assembler. But so to answer the question, there's two reasons. One, because you want to have some familiarity with it. You want to be able to look at assembly language and say, I know what that is because I've looked into this. And it's good to know kind of how code starts really high up here, JavaScript and Python, and ends up as binary executing on a CPU. And, of course, the CPU doesn't understand Python. There's always this translation. Okay, one more question. We're at 12:15, and then we're going to get into some code. I got a whole bunch of questions. I'm going to try to get to them all. I got about halfway through. I'm going to do one more, and then I'm going to move on to the code. Okay. What is the best programming language for artificial intelligence? Right now, I think it is Python, but I think if you want to achieve the highest level of performance, you're going to want to go for like C++. Okay, I'm going to get back to the rest of these questions, but we're going to get into some code. So let me make myself smaller here. And we'll get rid of that. And here we are. So I have a number of different languages here, and we're just going to start from the top. And then for each one, I'm just going to talk about kind of what it is, what it's for, its primary attributes, kind of where it came from, why it was created, just sort of just little tidbits of information about each language, and also why you would use it, because that's an important thing. If you came to this stream because you're maybe a new programmer or mid-level programmer and you're swimming in this sea of technology and programming languages and you just don't know, which one to grab for, which one to use, then we're gonna talk about them. But just so everybody knows the ones we're gonna do, we're gonna talk about C#, Go, Java, JavaScript, Perl, PHP, Python, Ruby, Assembler, C, C++, Julia, Kotlin, Objective-C, Rust, and SQL and Bash. And we'll spend about a couple minutes apiece. And we'll just go quickly through them. So it'll be good. So I'm just going to start from the top, and we'll just go from there. So I create a program. Actually, we'll do Python first because it's easy and everybody knows Python. Or most people here know Python. The program I created that I wanted to create for all these languages, I wrote all these myself except for a couple of them, which I asked help for to get them done. But essentially what this does is it takes two inputs. One is a starting number and one is a multiple number. And then what it does is it gives you the multiples of that number depending on however many you give. So if you give it like a 5 and a count 2, it'll give you 0 and 5. If you give it 5 and a count 5, it'll give you 0, 5, 10, 15, 20. And that's all the program does. And I just thought it would be a simple enough program to where it would show, command line arguments, it would show creating arrays, it would show loops, and then it would show just, some variables and how to work with them. So, Python, of course, everybody knows Python. If you haven't heard about Python, then I'm not sure. I'm not sure where you've been. Python is a massive language. It came out in 1991, made by Guido van Rossum, and he created it. I don't know the exact reason. I mean, that was back in the day of, like Perl, and of course C was there too. And he created kind of his general programming language, and it's dynamically typed. There is a type system in that things can be different types, but you don't see those types. You don't have to say like start num is an int. You just say start num equals, and then Python figures that out for you. So you don't have to worry about that. There's no memory management in Python. It's completely garbage collected, which means that once a variable goes out of scope, it simply cleans up the memory, and that's kind of that. It's an imperative language. It has some functional properties, but primarily it's just a really simple, brief, easy to write language, and it's also very fast. And it has a number of implementations. CPython is the primary one, but it also has IronPython, which runs on the I'm having a brain fart, Mono, or whatever the Microsoft, whatever runs C#. It also has that implementation. It also has Jython, which runs in the JVM, and then so it's kind of cool in that regard. It can run on different things. And as you see, there's no braces in Python. It's all based on indentation. So, and the indentation can be whatever. It doesn't have to be 4. It can be 2, as long as you're consistent with the indentation. And sometimes that gets people sort of tripped up, because if you have these really long routines that are highly indented, sometimes you can quickly lose track. So it's kind of a preference thing. You might like that or you might not. And for applications for Python, it has a lot of applications in artificial intelligence, a lot of applications in machine learning, a lot of applications in general systems programming, and as of probably the last decade, maybe 8 years, it's had applications in web. There's some really capable web framework projects out there that make Python a viable choice to do a web project. Those are things like Django and Flask, Pyramids, and WebPy. Okay, next one, we're just going to start at the top now. Now that you know the program we're writing, we're going to be doing it in the same. We're going to do the same program in every language. So next one's C#. Of course, this is a Microsoft language created in, I think, 2001, 2002 by Anders. His name's Anders Heilberg, something like that. And C# was created kind of as a. It's very similar to Java. It's very similar to Java in that if you take C# source and Java source, you'll see that a lot of the times they almost have one-to-one analogs in terms of how the code, converts over. So it's not exactly the same, and that's not true. That's not true of all the code in C#, but they are quite similar. However, as the languages get more modern, they start to diverge. But if you look at C#, say in the early 2010s, and you look at Java in the early 2010s, you would see that they're really similar in their structure, and they're really similar in how they do things. Now, C# is a statically typed language, which means that every time you establish a now in this case, like int start mum, it's funny, start num. So in this case, we have start num is the variable, and then we have int is the type. So you have to specify that. You have to say, like, this is an integer. And that's different from Python, where Python you just say start num equals 1. But C# you couldn't do that. You have to actually specify what the types are. But once you specify types, it starts looking kind of the same. I mean, the for loop looks a lot like Python. Some of the functions look a lot like Python. Of course, there's some output, that can take just variable type data. So it's kind of smart in this case, where like it's, C# can convert some of the types on the fly. Like sum is an integer and div is an integer, and it can sort of just concat an integer to a string to another integer, and it's totally cool with that. It'll do that. And that's kind of some of the stuff you're getting for free by way of just the language design, is you don't have to necessarily worry about, say, casting sum to a string, casting div to a string, something like that. Now, C# has basically a main function. Like C# has an entry point. Like Python executes from the top down, whereas C# has an entry point called static void main, and then this becomes the first line it executes, and then it just goes from there. And you have to specify a class, and you have to specify a main function. And then it has imports that you can use for various things. So C# has a wide range of uses. C# has applications in web, has applications in desktop programming, and it has applications in mobile programming if you're doing cross-platform development with some specific tools. Also, as Senior Ducky will tell you, it has a lot of application in game design. So C# is a pretty massive language that's quite ubiquitous for a lot of different use cases. Okay, next one we're looking at is Go. Oops, that's the binary. Okay, next one we're looking at is Go. Go is kind of a new kid on the block. This is a Google product. I want to say this has only been out for, let's see. Looks like first version was released 2019. So we got about a year. I'm sorry, got about 10 years. Go's been out about 10 years. And this is one of those things where Google likes to create their own stuff. Everybody knows that. Google says, well, we need a better programming language, so we'll just go create one. We'll make Go. We need a better web server, so they create Google Web Server. We need a better operating system, so they create Chrome OS. They're trying to create these products that compete with other products, and that's their whole business model. So why wouldn't programming languages be any different? So Go, however, Go is a good language, and Go has an interesting value prop. Go has a lot of memory safety. Go is very fast, and Go writes a lot like a dynamic language, but you get a binary at the end. So it is a compiled language in that there is a build step. You have to call Go build, and we don't have to call it, but if you want to create a binary, you got to call Go build. So you call Go build on your file, and then you get a binary at the end, and that's kind of cool because it's just a little thing that's totally packaged up, and it can be ran at any point in time. That's different than other languages where, like Python, you don't get a binary. Like you can't convert Python code to an executable binary that's ready to run right on the CPU. So with Go is similar to C# in that it has a type system. You have to specify. We don't have to specify types, but there are types. So you can use this : equals operator, and this will infer based on what the value you're putting into it. It'll infer kind of what that type is. So, A to I says convert string to an integer. So because I'm calling string_conv.a2i, Go already knows that start num is going to be an integer. Therefore, it's not necessary to say, start num is an integer. And again, this is another kind of neat thing that Go does for you. It just cuts down on the amount of code. However, it does come at a cost. It's less readable. When I look at this, I don't immediately know what the type is, other than I see string_conv.a2i. And because I see string_conv.a2i, I know it's an integer. So Go has a couple other properties. It has imports just like Java, C#, and other languages. And then it also has an entry point called main. And we'll see that a lot in a lot of different languages, where when you call a program, it immediately calls a main function, and then that program runs from that point on. And Go is no different in that case. Now, Go doesn't have a lot of parentheses. Like in other languages, the for loop, you'd have to wrap that in parentheses. Same thing here, same thing with the if. You have to wrap it in parentheses. Go does not require that. Also, Go does not require semicolons. You don't have to put semicolons. But beyond that, it looks a lot like a dynamic language, but it's not. It's a static language that makes a binary at the end. So kind of cool. Go has applications kind of in general programming. There are some web frameworks, but in March 2019, my professional opinion would not be to grab Golang for a web project. I don't think it's mature enough for that, which is to say there's not enough tools that can be used very easily, and that's why it's not a good language in that case. But if you're doing systems programming where you want blazing fast speed and you need a binary at the end, I would certainly select Go. Absolutely. Also, if you were writing like network software, maybe APIs or something like that, Go might also be a good pick. Okay, next one we're looking at is we're going to look at Java and Kotlin kind of together. And the reason we're looking at these together is they're very similar in that one can be created from the other. So Java, as everybody's heard of Java, of course. Java came out in 1996. It was written by, I think his name was James Gosling. And Java runs on the JVM, which is the Java Virtual Machine. And So Java code basically gets converted into Java bytecode, and then Java bytecode can be ran on the JVM. And that's also how Python gets away with it, is because they have that step, they don't have something that executes Java code, they have something that executes Java bytecode. And because of that, other things can be converted into Java bytecode. And then, I was just reminded about something. So Senior Ducky made the C# version for me. Forgot about that. He also made the C++ version, which we'll get to in a sec. So because Java bytecode is ran on the JVM, other things can create Java bytecode, which can then run on the JVM. So, Java here, actually, I'm going to pull up C# as well again. Because remember I said they're similar? And this is one example. Of course, these two lines were split out into 4. However, in Java, they're just 2, but it's essentially the same. That's the one for the list. Ints are basically the same. Ducky used a sum function and a count function, whereas in Java, it just got done manually. But so for Java, still has the imports. Java also has a main function, however, it's lowercase main. And then the same thing applies here. When this Java program is ran, it immediately runs in this main entry point. And then it starts executing from that point on. But from here, it's, Java's a static language, so you have to say integer start num, integer count. And then for the list, you have to specify this is a list, and you have to specify that the items in the list are integers. Remember, statically typed language. So you can't just say list equals brackets and then just put A1, true, none, and all this kind of garbage in it. You can't do that in Java. You have to specify the types that are going to be in the list. But once you're past all the typing, the for loop looks a lot like other languages, where you're just adding numbers into a list. And again, I'm creating sum and divisible, and I'm specifying that they are integers. In other languages, I don't have to specify integer because it's not typed. And then a for loop in Java looks a little different than the other ones. They do basically the iteration value, colon, and then the thing that you're iterating over. So in this case, num would be the number for every number in the list, and it would loop n number of times, where n is the length of the list. And then it prints it out. System.out.println is Java's. For C#, it's system.console.write. You can see that these are even the same. System, out, console, println, write. So it's even 3 words, just like Java. Very similar. If the C# code is written exactly like the Java code, it would look almost exactly like it. Okay, next one is Kotlin. So Kotlin, all I did to create the Kotlin code is I took the Java code and I put it into a Kotlin converter. So I select all, I copied it, I put it into a converter, and then it gave me this. So you can see that once again, it's a lot of it's exactly the same, like integer.parseInt. However, you can see that I didn't have to do integer start num. One of the things that Kotlin gives you is Kotlin gives you the ability to kind of ignore types that are inferred. So in this case, Kotlin lets you put val because you don't have to put integer, because it's very clear that integer.parseInt returns an integer. Therefore, putting integer here would just be redundant. So Kotlin lets you reduce your amount of code by allowing you to use things like val. And C# also lets you do that. You can do var as long as the type can be inferred. And a lot of these languages are going to this sort of inferred type system. Even C++ has the auto keyword, and that's exactly what that's for, is to just allow the type to be inferred based on what the expression returns. So Kotlin has really, instead of integer everywhere, it just has val, because it's inferring the type based on what comes next. Of course, Kotlin does not require semicolons, whereas Java does. The for loop is almost the same, and then the rest of this is basically the same. Instead of system.out.println, it's reduced to just println. So Kotlin basically took Java and just ripped out a lot of the fluff syntax and just made it a little nicer to look at. Also, the function signatures are a little different. Java does type and then name, whereas Kotlin does name : type. So it's slightly changed there. However, Kotlin can use anything Java can import because it is basically Java. Now, as far as use cases, Kotlin and Java have, well, actually, we'll start with Kotlin. So Kotlin was created by the JetBrains people, and it's used almost exclusively in Android development. So if you're writing Android apps as of the beginning of 2018, I think is when it came out, maybe even late 2017, you can write your Android apps in Kotlin. And because Kotlin is basically Java, it runs perfectly fine. They did that so they wouldn't have to actually change the back end, of Android. They kind of just made it all compatible. And so that's really Kotlin's only use case. Java's use case, however, is everything. It has use cases in web, in desktop development, in systems programming. I'm sure some use cases in AI. Of course, Java is still ubiquitous in Android. You don't have to use Kotlin if you're making Android apps. So so Avi12 said Kotlin isn't exclusive to Android. Definitely not. It's not exclusive to Android. However, I believe that's why it was created. That's the market they were going after, because the JetBrains people also do Android Studio. Or not? Well, they don't do Android Studio. They built the what's it called? IntelliJ. Yeah, IntelliJ platform. So they built the platform for Android Studio, and whoever the Android Studio people are, I'm guessing Google or something like that, they are kind of the stewards of that program. But I've only ever seen Kotlin in Android. I'm sure it could replace Java. However, that's going to be a tough sell. There's a lot of Java developers out there, and I don't know how keen they are to be, how keen they are on switching over. Okay, next one is JavaScript. JavaScript, we all know JavaScript. JavaScript's everywhere. JavaScript is a dynamically typed language. It's interpreted. It runs from top to bottom. It's not the fastest language, of course, just by nature of what it is. However, it is very widely deployed. You can find JavaScript everywhere. It's the only language in your browser. There's a little asterisk there, for only. Of course, they're working other technology into browsers. However, JavaScript is the only one that you can count on. It's the only one that you can count on to be there. ECMA 266. So of course, with the advent of Node.js, JavaScript now has use cases on the server side. Very, very modern JavaScript too, not like the old dinosaur JavaScript in the browser. You have very modern JavaScript. There's a moduling system for JavaScript called NPM, which contains hundreds of thousands of modules that are just pre-built code for JavaScript for quite literally anything. If you're a Raspberry Pi people, if you're big on Raspberry Pi, there's tons of different modules for that. Yeah, Avi12 just mentioned Electron, Cordova. So if you're doing HTML5 apps, like PhoneGap and Cordova, you can make mobile apps with JavaScript. Of course, React Native is in JavaScript. Electron is essentially if you use the Discord app, not on your phone, but on your computer, that's written in Electron. Electron is essentially a Google Chrome tab with a bunch of different APIs people can access, and it's all in JavaScript. So JavaScript's massive. If you don't know it, you should check it out, because you're going to need to know it in 2019 and beyond. Not a ton of use on the server side and I don't mean like web, it has a lot of use on the server side, but as far as like systems programming, high performance programming, not really a language people might use, but that's okay. It can't do everything. Okay, next one is Perl and PHP. We're going to talk about sort of together. Start with PHP first. So PHP is primarily just a web language. It's a dynamic language. It runs from top to bottom. All the variables start with a $sign. That's kind of the PHP way of defining a variable. But past that, it looks a lot like Python. The brackets, that's the same as Python and JavaScript. The for loop is almost exactly the same as every other language. Array push is their function for taking an element and pushing it onto an array. And then their for loop is a little different. They do for each something as something else. Whereas Python, like this is for each list as num, whereas Python would be for num in list. So similar, but does the same thing. And the rest of it's the same. So PHP should look a lot like JavaScript and a lot like Python to a lot of people. If you take out all the $signs and you swap out a couple keywords, then you essentially have Python code. PHP has use cases. PHP was originally built for the web only. It was made by Andy Gutmans, Zeev Sarasky, and some other guy, Rasmus Lordorf was his name, I think. Those three guys, two Israeli guys, one, who was he, Dutch? I think he was Dutch guy. They built PHP specifically for the web. That was absolutely what it was made for. In fact, PHP, used to stand for personal homepage or pretty homepage, and then eventually was renamed as a recursive acronym. PHP stood for PHP Hypertext Preprocessor, and you can do other things with PHP. In fact, there's a good text out there. It's called You Want to Do What with PHP? And they talk about doing like audio encoding and video encoding and all this crazy nonsense with PHP. So there are things you can do with it, but you probably shouldn't. It's kind of the whole thing like, well, you can rob a bank, but should you rob a bank? The answer is no. So if you're getting into web development and you want a extremely widely deployed language that's going to be present on almost any server out there, along with Apache, and you want to just get going quick, you don't want to deal with any BS, then PHP might be an okay option for you. So Perl. Now Perl, I took some sample code because I didn't have the right Perl version. I had the older one. So Perl is a really old language. I think it was created by Larry Wall back in it's got to be 80s. Let's see here. Let's see. Perl first appeared in 1987. Whew, that's been a long time. 31 years. So Perl, though not super popular these days. Now, when I say super popular, I don't know a lot of people who are grabbing for Perl as they're like, we have a fresh slate, we can pick any technology we want, we're going to pick Perl. People don't, like, I wouldn't do that. I mean, maybe there's people out there that do, but I would not. However, Perl did influence a lot of people's work. In fact, if you look at a lot of languages out there, if you go into like their wiki page and you look at their history, you'll see that each one has an influenced by and has an influenced. And you'll see that a lot of languages out there were influenced by Perl. So even though it's not, like just looking in here, chomp is a Ruby keyword, die is a PHP keyword, print is a Python keyword, usestrict is a JavaScript keyword, the $sign's in PHP. So, like, I'm looking at this and I see 4 different languages worth of stuff that they stole from Perl, and I think that's kind of cool. So Perl, though not super popular in 2019, has influenced a lot of the languages that are extremely popular. Now, That said, at least for Linux, it would be very difficult. It would be extremely difficult to find any Linux distro built probably after 1995 that does not have Perl already installed. So that's one good thing about Perl is you can count on Perl to be there for you on your Linux server no matter what version, no matter what time. So, however, Python will slowly take that over. Python 2.7 has been ubiquitous as pre-installed to almost every Linux distro pretty much in the past at least decade or longer. Probably longer. Probably since the late 90s, I would say, maybe in the early 2000s. Yeah, probably early 2000s you can expect some version of Python to be on your Linux distro without having to install anything. So that is definitely something that it does. As far as use cases for Perl, certainly it's great for systems programming. There's still a lot of things on Linux that have Perl build systems and a lot of things that depend on Perl. So even though it's not widely popular today, it's not going anywhere because people still use it all the time for existing tools. And it used to be big time language on the web, but not so much anymore. I'm sure if you're a web developer, you're going to come across some legacy code that's going to be in Perl. There's just going to be no way to avoid it. All right, next is Ruby. So Ruby is a lot like Python. In fact, everything about Ruby, I used to call Ruby Python for hipsters. That's what I used to call it. But the Ruby is so simple that it's not simple. And I know that that's a statement that doesn't make any sense, but in programming, it's like what level of abstraction can you tolerate? So Ruby is so simple that it's tough to use sometimes. And that's especially true if you're using Ruby on Rails, because Rails introduces a lot of different things that just look weird in Ruby. But so if we compare this to the Python code, it's almost exactly the same, except Ruby doesn't use braces either. However, Ruby does use keywords to signify the end of loops and the end of if statements and the end of functions and things like that. So it does do that. It is dynamic typed. Of course, this is exactly the same as Python. That's exactly the same as Python. These are exactly the same as Python other than the keywords. The way iterations work are a little different. Ruby does list.each, do, and then in pipe symbols you can put num or you can put whatever. And so list.each do num is going to be the equivalent of for num in list, in Python. And then put string, and that supports string interpolation. And then they have a couple different ways to cast to different variables, like 2i is to integer, 2s is to string. Python has that as well, but they have int and str, which can cast to different things. But very similar. If you compare this to Python, it's quite close. Quite close. It's also very, very brief. Ruby was made, I think, in 1999. I think 99, 98, around there by, I can't remember his name, Yukihiro Matsumoto, I think his name. And I don't know of a lot of people that use Ruby outside of hacking and Ruby on Rails. In fact, I've met a lot of people in my career that say, I don't know Ruby, I know Rails. And it's a ridiculous statement, but it has some merit because Rails, I believe, is what propelled Ruby. Oh, I got it. Nice. Nice, Jared. So the Rails, I believe, is what propelled Ruby into the spotlight. As soon as they released this massive, all-encompassing web framework that we know as Rails, which is an extremely powerful web framework. You should check it out if you've done any Ruby programming. I think that's what kind of put it into the spotlight. But it's not it's not a chump language. It's just as powerful as Python, just with different syntax. Yeah, Michael Heward, Ruby is badass for Metasploit. Yep. Yeah, there's all the exploits in Metasploit are in Ruby, and a lot of the times, sometimes I track those. I go to the Offensive Security DB and I look at those different exploits, and a lot of them are in Ruby. It's a solid choice for people that are in that sort of space. I'm not really in that space, so I don't use it that much. I do have a Rails project out there just because I wanted to do something in it, but I don't use Ruby all that often. Okay, next is C. So we all know and love C. C was made by Dennis Ritchie back in 1974, 75, 70, mid 70s, and it's kind of the language. It's been around now, what, 45 years, and it's done something very special. C has been the one language that has survived the passage of time, and that's because C is the language which is, by today's standards, still considered. So by previous standards, they would have called this language a high-level language because it's a lot higher than assembly. But these days, there are languages that are a lot easier to use. So I like to call it like a middle-level language. And C is special because it's very small. It's not bloated. It's not massive. It doesn't have a ton of standard libraries. It leaves a lot of the decisions up to the programmer. And because of that, it's extremely fast and it's pretty portable. And it has a lot of different use cases. But C's the thing where, first of all, everything was written in C. You know, like Python, the Python compiler at some point was written in C. You know, the Python people will say, well, Python's written in Python, and they're right. It is, but not in the beginning. You know, there's this concept of bootstrapping whereby you kind of, if I use an analogy in the real world, you know, how did we build the hammer without the hammer? Well, we use a hammer to build a hammer, but how did we build the first hammer before hammers existed? Well, easy. We took a piece of metal and we started banging it against something, and we formed something that was kind of like a hammer, and then we used that kind of hammer thing to smash a better hammer, and then eventually we forged the first hammer. And then we used that hammer to forge 10,000 hammers, and then on and on and on. So the same thing applies in languages. So like the PHP was written in C, Python was written in C, Julia was written in C, Perl was written in C, JavaScript was written in C++. I'm sure Go was written in C at first. You know, everything starts out as C. It all starts out as C. So it's an extremely important language. Now, C allows you to do manual memory management. So you have to say, I want to establish 5 bytes of memory, and then I will use those 5 bytes of memory. So in this case, I create a list of 0 bytes, and then for every number that shows up, I add an additional byte of memory, and then I set a value in that block of memory. And then I do my operation, and at the end I have to free that memory. I have to say, operating system, you can have this memory back, I no longer need it. And this is a very manual thing. However, it's extremely important because you need to be able to manage memory very efficiently when you're doing low-level programming. And somebody mentioned in chat here the Linux kernel. The entire Linux kernel is written in C, the whole thing. And some of it's also written in hand-coded assembly, but the majority of it is in C. Yep, Frederick Hamill, sorry if I messed up your name. C compiler is in C. It's a fantastic thing. So GCC compiles C code, but GCC is written in C. So where did GCC come from? Well, easy. You know, there was this language called Algol 57, and it was used to write a compiler for some other language, and then Algol something else, and then B, and then C, and then over, like the first C compiler was written in B, the B programming language. However, once you write enough code in B to make a good enough C compiler to start writing language features in C, you can totally take B and just remove it from the equation. It's a crazy meta topic, and I'm happy to go into it again on Discord if you want, or some other video. But it's this concept of bootstrapping, and that's how a target language can be written in itself. Simple as that. You just keep writing new language features, and then eventually you have a language that you can use to write new language features. You just keep doing that. You're basically just snowballing this thing into the language that it is today. However, just as an anecdote, it does have kind of a spooky property whereby you can use GCC to compile a version of GCC that has a backdoor in it, and then you can remove that backdoor and compile that version with the backdoor GCC, and then now you have a version of GCC with no backdoor, but it still has a backdoor from earlier when you put it in there. So it's kind of a spooky, weird sort of thing, where you have this snowballed, binary full of who the hell knows what. Anyways, so that's C. We'll just roll into C++. Kind of the same as C. However, C++ gives you a lot of what we call abstractions, and essentially what an abstraction is it's a way to make a language a little bit nicer at sometimes the cost of a little performance overhead. C++ does a lot of things that are not costly or have no cost at all. However, C++ loses a bit of portability by creating tons of new features. And that's a hotly debated topic between the C and C++ guys. If you want to look at a good rant, look up Linus Torvalds, who wrote Linux. Look up what he thinks about C++ and his reasoning behind that. But the C++ is supposed to be, C++, like it's an enhanced version. So a lot of the same syntax you'll find in C++, a lot of C code, if not all of C code, and I'll let Ducky follow up with this in the chat, but most, if not all, C code is also valid C++. In fact, most of the time you can use the C++ compiler to compile C code. The same is not true in the reverse. Like GCC, the C compiler won't compile C++ code. Also, Ducky wrote this for me. He wrote this code. All right, what we got left? We got like 3 minutes, 4 minutes. The stream's gonna go a little long. We're gonna talk about Rust. I'd be upset if I didn't sneak Rust in here. So Rust is this new kind of kid on the block. Rust has only been around for, I think it hit 1.0 in 2014, and Rust has a lot of interesting properties. Rust's big value prop is really stable code, really blazing fast code, and lots of abstractions that come at zero cost. And that's kind of their value prop. And they also have very, very tight memory controls and thread safety. Basically, the language it's supposed to be so stable that you never run into a seg fault. Otherwise, it would never compile. I'm thinking the Rust guys, in their mind, one of their design philosophies is if we compile a code successfully and it seg faults, we've violated our own principles. So Rust was made by the Mozilla guys, the same people that made Firefox, and it's kind of a language they're putting a lot of horsepower behind it. They're putting a lot of manpower behind it to make it work, and it's kind of a cool language. I like how it writes. I think it's neat. However, with all the guarantees that they give you, abstraction is a synonym for feature, right? Yes, yeah. It is. Features come at a cost. However, Rust tries to give you features at no cost. However, with such strong guarantees that Rust gives you, what it does lead to is it is difficult to write. Like the type system in Rust is very complex. It's beyond my knowledge complex. I don't fully understand it. I can write really basic Rust. I mean, I wrote this, but I don't know how much more I could write in Rust. But it's on my list of things to learn better. And it should be on your list of things to at least look at. As far as use cases for Rust, it's primarily for systems programming. That's what they want it used for. But just like anything else, there is a web framework for it. There is an HTTP library for it. So you could theoretically write websites in it. You could theoretically write APIs in it. But its really strong power is high performance, systems level programs. Okay, we're going to look at SQL real quick. So SQL is for databases. It's a structured query language, and this is just generic SQL. These are 3 commands: select, update, and delete, that should work on almost any database. It should work on Postgres. It should work on MySQL. It should work on Microsoft SQL Server, T-SQL. So it should work on all that. So like most databases implement this language called SQL, and they implement not 100% of the SQL standard, but then they implement a bunch of implementation specific stuff. Like T-SQL has the top command, whereas MySQL doesn't. And Postgres has a lot of geo stuff that MySQL doesn't. And I'm sure MySQL has things that Postgres doesn't. So you can expect that a lot of your SQL knowledge is transferable across all these database platforms. But you should know that each one of them implements some additional things. And of course, use cases for this, it's all just databases. We're talking 100% about databases, and there's no application for SQL outside of interacting with a database. And of course, assembly. The last one will be assembly. I'll do like 5 minutes questions, and I think that we're pretty much it. We're pretty much done. That's the hour. So here's your assembly. This is hello world in assembly. And this is eventually what all your C code ends up. Your Python code ends up as bytecode, the bytecode ends up as assembly. Assembly has a one-to-one analog to actual machine instructions, and then it runs on the CPU. So what you're actually saying here is, we're saying move the value of 4 into the EAX register. We're talking about actually putting values in CPU registers. And then we're talking about calling interrupts on that CPU. ADH is an interrupt that says, I'm going to mess this up. It basically says, come call this function. Come call the values that are in the memory registers. So, put 4 into EAX, put 1 into EBX. I think 4 is the write command, and then 1 I believe is standard out. So that goes into EBX. And then ECX is going to be the actual data to write. EDX is going to be the length of that data to write. And then interrupt. And then 1 I believe is exit. EBX. 0 is put the 0 code into the exit function, and then interrupt again. So it's good to know what this is, but it's not super useful for everyday programming. Like, you could still be an effective Python programmer, JavaScript programmer, without looking at a single bit of assembly. So this is one example of assembly language. There's a couple different dialects of assembly language. There's gas syntax, and then there's NASM, MASM, I think. Anyway, so different variants of assembly language based on, I said dialect, but it's not dialect. It's, I don't know what it's called. I'm sorry, I'm having a brain fart at the moment. But that's assembly language. It's very specific. It's very difficult to write, but you should at least you should at least know what assembly language is. You should be able to look at something and say that's assembly language. I mean, that would certainly be a good start. Okay, we've covered all the languages I plan on covering. There's a couple other obscure ones that I had, but we don't really have the time for them. So I'm going to do a few more questions, and then we'll get this wrapped up. I have like 50 questions. There's no way I'm going to get to all of these. I'm going to pick just the ones that are related to. Yeah, okay. Would you prefer more C, C++, or Rust? Right now, I prefer C for anything performance related. However, as these other tools begin to mature, such as Rust, I would certainly take a peek at. I mean, we're never going to replace C, but you could probably replace C++ with Rust. But I don't think you could ever replace C with Rust. Let's see. How you create kind of knowledge. Kellyanne Ruth asked, what kind of knowledge is required to learn assembly? So the knowledge is in CPU architecture. You have to understand how a CPU executes certain instructions, like jump commands or adding or putting memory into putting values into registers. You have to understand all those things, the absolute lowest level. Once you understand all that, then assembly language starts making more sense. But if you're a person watching the stream right now and you don't have a whole lot of experience with CPU architecture and you're not sure how a CPU is actually making things happen, then assembly language is probably going to be very difficult for you. Mitchell Turley asked, how many languages do you know? I know about, I would say I have working proficiency in roughly 12 or 13 of them, but I have fluency in about 5 of them. And they're just the ones that I use every day all the time. Zach Koch asked, what is the meaning of life? The meaning of life is to do the best you can at whatever you're doing and always enjoy every minute of every day and then die happy. That's the meaning of life. There's my deep stream comment. Okay, a couple more questions. I'm going to answer this one. It's not super related, but it does bring up an interesting question. How long do you reckon before quantum computers become readily available to the public? I think it's a while, but I think the better question is, once quantum computers are available, are we going to have something like C quantum? Are we going to have quantum C? You know, what is that going to mean for the world of programming? Or thanks a lot for the 10, Zach. Also, thanks for the question. Long time staff member, long time supporter. Thanks a lot. Good to have you. It's like what's that going to look like? What is the computing landscape going to look like when quantum computers are here, and how will we interact with these computers? Or will it just be we'll have our classic, because today they call them classic computers. Classic computing is kind of what we do today. And the only reason that we need this term called classic computing is because we have things occurring in the future that are not so classic, such as quantum computing. And will it just be that we apply quantum computing to very specific problems that can only be solved with quantum computing? If that's the case, we won't need kind of a quantum C equivalent. We would just need a way to interact with quantum computers. Bukhar Gary asked, how old are you? I am 33. No. Yeah, 33. I'm getting to that age where I don't remember my age anymore. All right, one more question, then we're going to wrap it up. Pick a good one here. I'll answer this one. React Native or Flutter, which is better? I'm going to answer this only because I've just been messing with it. I think React Native is more mature. However, Flutter makes it really, well, you know what? It's just like they wrote on the box. It says create beautiful UIs really fast. You know, native apps with beautiful UIs really fast. And it absolutely does that. I tried making a very small Flutter app, went through a tutorial, did a couple different things, and I was really surprised at what it produced. So I think Flutter has a lot of potential. It's not going to overtake React Native in the near term because there's tons of React Native talent out there and tons of React Native tutorials and projects and ways for people to get better. However, Flutter is an up and coming. I think in today in March 2019, you should definitely go try out the Flutter tutorial and at least get your feet wet in it for sure. Okay, we've reached the end of the stream, so I just want to say thanks to a lot of the people. Thanks to Pizza for checking over my Go code to make sure it wasn't anything wrong with it. Thanks a lot to Ducky for doing up the C# and C++ versions of this stream content. Thanks to Zach for the good question, donations. Thanks to the rest of my staff for attending almost every stream. Couldn't do this without you. Thanks to all the regulars who show up to all the streams. I'm constantly seeing the same names in the streams, and that's really great because it's you like what I'm presenting enough to kind of keep coming back. So like Shreyas, I'm constantly seeing you here. FN13, I'm constantly seeing you here. Of course, Tomatu, I'm always seeing you here. Justoy, seeing you here a bunch, as well as several other people. So thanks a lot to all the regular people, or sorry, not the regular people, all the regulars who come to the stream. So last is, if you are not on the Discord server, on the Engineer Man Discord server, you should get over there and check it out. Somebody will post the link here in a second. And there's a lot of stuff going on the Discord server. We got about 4,000 people on there with about 700 or 800 active at any given time. We have a lot of different resources, a lot of different channels, and a lot of really smart people. The staff I have, they're very good, very smart. They keep a really nice environment in the server, so you're not going to come across any nonsense. It's a good server to be on. It's highly curated, and I also interact with it. If you want to come chat with me, come in there and ping me. If you want to say hi to me, go ahead and shoot me a message because I'll respond. I don't block people's messages. I let people do what they're going to do. So definitely, yeah, good point, Zach. It's not just programming. It's technology as a whole. So there's also networking, there's security, there's ethical hacking, and pen testing. Ethical stuff only. We don't condone any hacking on the server, but certainly certainly there are people that keep people safe, and that's the sort of stuff that we discuss. There's a bot on the server which can run code, and there's also emkc.org, which has a bunch of different challenges that you can do, and as you finish challenges, you get points, which lead to better roles in the server, and you can show off your code there. Other than that, I think that's it. Thanks a lot for attending the stream. I really appreciate it. It was great to see everybody. I hope everybody enjoyed it. I apologize that it was 1 week late. For the video tomorrow, I'm planning on getting the Docker Compose video out for tomorrow at the latest in the evening. Other than that, look out for the video, and I hope to see you on the Discord server, and let's chat about that. Other than that, see everybody later.